Welcome, and today I want us to talk about median and specifically how to determine the value of median in a grouped data. Now, when we talk about group data, we are referring to data which has been classified into classes. For example, we are told that the following data relates to share prices of 1,000 companies listed in a regional stock market. So we have the classes from 100 to 120 all the way to 220 to 240. And number of companies is 18 for the first class all the way to 3 for the last class. It means that when you add these ones, the number of companies should give you 1,000. And this one refers to the frequency. Like for example, the class of 100 to 120, we have 18 companies having the share price under that class. So, for us to determine the median, in this particular case, I want us to recall what median is specifically. And median refers to the value of the middle term in a data of odd numbers. So if you add data of odd, for example, data of 1, 2, 3, it means the median should be the one in the middle. But the other definition, when a given even numbers, it means that the mean of the two middle terms in a data of even numbers should be referred to the median. For example, if we have x, y, z, o, these are even numbers, they are 4 in numbers, okay? So it means the mean of the middle two terms. So the middle two terms should be y and x. So it should be y plus z divided by 2, which is the mean, should refer to the median in this case. But now, for the case of group data, now in group data, median is determined by linear interpolation using the formula. And the formula that we normally use in group data is M is equal to L subscript L small plus U subscript L minus L subscript L divided by F into M minus C, where this one is now the value of the median that we are looking for, the first M. Then we have L should be the lower limit of the class to which median lies. So the word lower limit means, for example, if you have a class of 100 to 120, this one is the lower limit. And UL is the upper limit to which median lies. So this one is the upper limit, for example. Then we have F is the frequency of the class in which median lies. How many times does the data occur in that particular class? We're going to see that. Then small m, which is very important now, refers to the middle item, which is normally given by L plus 1 divided by 2. And L in this case is the total number of items. In other words, the cumulative frequency. That is N, we get N by adding all the number of occurrence, or we get it by adding all the frequencies. We are going to see that. Then of course C refers to the cumulative frequency preceding the median class. That is the cumulative frequency that comes just before the median class. So essentially, if you look at all these, it means that we are supposed to get the value of L for us to obtain all this and apply in the equation. So essentially, it means that getting the value of L, we must first of all get the cumulative frequency. And in this case, we are going to add all the frequencies. For example, when this one should be 18. 18 plus 54 should be 72. 72 plus 200 should be 272. 190 plus 272 should be 462. Yes. Then 330 plus 462 should be equivalent to 792. Then when you add this one, you're supposed to get 792. 792 plus 205. 205 is supposed to get 99997. And then 997 plus this is supposed to give 1,000. So essentially our cumulative frequency is 1,000, just the way we are told in the question. So we have confirmed. So it means our m small is 1,000. So it means for us to get m, so getting m will be given by this one here. I mean by this is our end, sorry. So getting m should be equal to 1,000 plus 1 divided by 2. So that is 101, 1,000 and 1 divided by 2. We get a value of 500.5. That is our small n. Then now, so it means that when you use this value, we are supposed to get, this one should give us the class to which the median lies. Essentially, it means that this value is found within 700. It is above 462. It is found within 792. So it means our median lies in this class, because this one will be submerged all over this one. So our median class is 180 to 200. So it means that when we apply this one in our equation, we have our lower class, which is this one is our lower class. This one will be our upper class. We have our frequency for the median class, which will be 330. This one will be our frequency. And we have cumulative frequency C, which we said that C refers to the cumulative frequency preceding the median class. So preceding means the one that comes just before the median class. And our median class is this one. So it means the one becoming before median class is 462. So this one becomes our C. So we apply all these one in our equation to obtain what we need. So m should be lower class plus upper class minus lower class divided by the frequency in that class into m minus c. So it means that m should be equal to the lower class, which is 180 plus into upper class is 200 minus 180 divided by 330. That is 330, the frequency in that class. You multiply this one by 500.5, which is the value of m, minus 462. This one is supposed to get a value of, should be 180 plus, this is 20 divided by 330, it's supposed to be 0.03. that one times, we have 500.5 minus 462. We should get a value of 2.333. So our answer is supposed to be approximately 182.233. We round off to the nearest, so it means this is our median. It lies within this class here. Thank you. Please don't forget to subscribe.